review how we can multiply and divide fractions. So the important thing to keep in mind is that we do not need a common denominator when we are multiplying or dividing. We only need to have a common denominator if you are adding or subtracting fractions. So for this entire review, you do not need to worry about getting the same number in both denominators. When it comes to multiplying fractions, we always multiply going directly across the numerator and directly across the denominator. So if we wanted to multiply 2/5 by 3/4, we would multiply the numerators 2 times 3 and get 6, and we would multiply the denominators 5 times 4 and end up getting 20. Now, one thing we do always want to try is to simplify our fractions if it is possible. Simplifying a fraction just means we want to divide the numerator and denominator by the same value so that both the numerator and denominator have smaller numbers appearing in them. So for example, 6 and 20 are both divisible by 2, so 6 over 20 would be rewritten as 3 over 10. This has the same value as 6 over 20, but because it is simplified, it is often easier to identify, easier to work with, and is the preferred form of a fraction. From here, pretty much through the rest of your years of taking math classes, your teachers will almost always want you to simplify your fractions if your answer is ending up in a fraction form. So let's go ahead and practice just a couple of these examples here. So if I'm looking at these problems, I have two fractions that I am multiplying together. I do not need to worry about getting common denominators, so I can just go ahead and multiply directly across. So if we multiply across, that means we'll have 1 times 1 in the numerator, and in the denominator we'll have 2 times 5. So 1 times 1 is 1, and 2 times 5 is 10. So our final answer is 1/10. If we look over here, or let's look down here at question 4 actually, we can go ahead and multiply across. If we do that, we would end up getting 2 times 7 over 5 times 8. So 2 times 7 is 14, 5 times 8 is 40. Now 14 and 40 we can simplify. We can divide those both by 2. So if we divide these both by 2 over 2, 14 divided by 2 is 7, 40 divided by 2 is 20, so we should end up with 7 over 20. Now, there is another option for how we could work through this, and that's what's shown in this graphic up here at the top of the page. We can actually simplify or cancel out before we multiply. By doing this, we can pick one of the numerators and one of the denominators and divide both of those numbers by the same value. So in this example, the student picked 6 and 3 and divided those both by 3. So 6 divided by 3 is 2, 3 divided by 3 is 1, so we're left with a 1 down here in the denominator and a 2 up here in the numerator. So we've essentially canceled out or simplified 6 and 3. You can go through the same process with 2 and 10, so 2 and 10 are both divisible by 2. So 2 divided by 2 is 1, 10 divided by 2 is 5, so we end up with 1 and 5. The benefit of canceling things out or sort of pre-simplifying your fraction before you multiply is that 1, you're working with much smaller numbers. You don't need to worry about multiplying by 6 or multiplying by 10. And 2, oftentimes you then do not need to worry about simplifying at the end of multiplying. So we end up multiplying 1 times 2 is 2, 1 times 5 is 5, so we end up with 2 over 5 or 2/5. We cannot simplify this anymore. However, if we just multiply directly across, 2 times 6 is 12, 3 times 10 is 30, we would be able to simplify 12 over 30. I recommend make your life easier and try to simplify before or cancel out before you multiply. So if we look at question 4, we could achieve that by picking 2 and 8. The numbers 2 and 8 are both divisible by 2. So 2 divided by 2 is 1, 8 divided by 2 is 4. So this would now become 1 times 7. So I'll show this down here. This would become 1 times 7 over 5 times 4, which, sure enough, 1 times 7 is 7, 5 times 4 is 20, so we still end up with 7 over 20. So either of these strategies work. They give you the same answer. However, I've found that students tend to be more accurate in correctly getting the final simplified answer if they start out with canceling out the numbers first. Sometimes students just forget to simplify at the end because they're so excited to have found an answer, they forget to check to see if they can simplify it. So I recommend, when possible, do try to cancel things out before you multiply across. So if we have fractions where the two numbers we're multiplying together are written in a typical fraction form, that's very nice for us to work with. Sometimes, however, like the examples we see on the right side of the page, we have mixed numbers or other things just that aren't quite in the same format. So if we are multiplying together a fraction and a mixed number, the key is we cannot keep the mixed number in that form. We need to change it into an improper fraction. So for example, 3 and 2/5, we would multiply the whole number times the denominator, so 3 times 5, and then we add whatever is in the numerator to that. So 15 plus 2 is 17. Our denominator will stay the same. So this 3 and 2/5 will become 17 over 5. Once it's in this form, then we could go ahead and do our multiplication. So we can also see this process written out here, where you can change 2 and 2/3 into the improper fraction 8 over 3. Once we have it in that format, we can then multiply across, and at the end you can simplify. So let's look at example 9 here. So we have 2/5 times 2 and 11/12. So I need to first change my mixed number into an improper fraction. So this will become 2 over 5 times, well, we can change this mixed number to an improper fraction by doing 2 times 12, which is 24, plus the numerator, which is 11. So 24 plus 11 will be 35. And we put this over the denominator of 12. Now, before I go ahead and multiply across, I do want to try to cancel things out first. So if I'm looking here, I can pick any number from the numerator and any number from the denominator and divide them both by the same value. So I'm going to pick 2 and 12. These are both even numbers, so I can divide them both by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. And if I'm looking at the 35 and 5, I can also simplify both of those. I'll use a different color to represent that. So for this, we can divide both 5 and 35 by 5. So 5 divided by 5 is 1. 35 divided by 5 is 7. So now I no longer need to worry about multiplying 2 times 35. Instead, I can just do 1 times 7, which is much nicer. So we have 1 times 7 over 1 times 6, so our final answer will be 7 over 6. Now, it is perfectly acceptable to leave your answer written as an improper fraction. Some teachers may have a preference and ask you to change it from an improper fraction back to a mixed number. So just make sure you check with your teacher to see what their expectations are for dealing with improper fractions. The next example we're going to look at down here is question 12. So for question 12, here we have a whole number times a mixed number. So if we want to multiply a whole number times a mixed number, we need to both get them into a normal fraction form. Now, we can take any whole number or any integer and easily turn that into a fraction by taking that number and putting that over 1. So 28 can turn into the fraction 28 over 1. Next, we need to multiply this by 8 and 2/7. So I need to take 8 and 2/7 and turn that into an improper fraction. We know the denominator will stay the same, so the denominator will stay 12. To figure out what goes in the numerator, we can do the whole number times the denominator, so 8 times 7 is 56, and we add the numerator to that, so we end up getting 58. So our new problem is 28 over 1 times 58 over 7. Now, I personally am not interested in multiplying 28 times 58 to figure out what that becomes, so I want to see if I can simplify this at all. And thankfully, 28 and 7 are both divisible by 7. So we can go ahead and do 7 divided by 7 is 1. 28 divided by 7 leaves us with 4. So this problem is now 4 times 58 all over 1 times 1. Well, 4 times 58, if you go through that multiplication process, you end up getting 232, and 1 times 1 is just 1, so our final answer, we can simplify this back into a whole number, is just 232. Oops, sorry, we went off the screen. There we go, 232. So keep in mind, if you have a mixed number, you want to rewrite that as an improper fraction, and if you have a whole number or an integer, you can also rewrite that as a fraction by putting that over a denominator of 1. Next up, we're going to review how we can divide fractions. The good news is it's going to be a very similar process to what we've just been doing with multiplying fractions. So let's look at a couple of examples there. So just like with multiplying fractions, you do not need a common denominator when you are dividing fractions. So if we look at this first example here, if we are dividing a fraction by a fraction, for example, 1/3 divided by 2/5, it's very difficult for us to go through and try to calculate out dividing by a fraction. Usually you think of division as splitting something up into a certain amount of groups or a certain amount of pieces in each group, and therefore it can be really difficult to visualize breaking 1/3 into 2/5 groups or into chunks of 2/5. So thankfully, what we can do instead is we can rewrite a division problem as multiplying by the reciprocal. So to multiply by the reciprocal, you take the fraction that is doing the dividing, so that is the second number, and you rewrite it as the reciprocal, or you flip the fraction or invert the fraction. So 2/5, 2/5, its reciprocal will be 5/2. So you take the numerator and denominator and swap them. Next, we need to make sure we change the operation. So it will no longer be dividing, it will instead be its opposite operation, or the inverse operation, which is multiplying. So something you might hear from other videos or other resources is the phrase keep, change, flip. This works as long as you're only dealing with a 2-number situation where you're dividing 2 fractions. This process does not work as well if you are working with multiple fractions, 3 or 4 fractions in a more complicated multiplication division problem. So I strongly recommend that instead of keep, change, flip, you try to memorize the phrase multiply by the reciprocal. This will always work whenever you are dividing by a fraction. You instead multiply by the reciprocal of that fraction. So let's practice using working through a couple of these examples here. So as always, our instructions say to write our answer in simplest form, so we do want to make sure that we simplify. So if we're looking at this first example, 3/8 divided by 15/16. I am dividing by a fraction because the second number in this division problem is a fraction. So I instead want to multiply by the reciprocal. So my first number stays the same. That's our starting number. That does not change. Instead of division, I will use multiplication. And instead of the fraction 15/16, I will use the reciprocal, which is where you invert the fraction. So this will become 16/15. Now, before I go multiplying across, I really don't like dealing with such large numbers. Thankfully, we can cancel things out. So 8 and 16, we can divide those both by 8. So 8 divided by 8 is 1, 16 divided by 8 is 2. And if we're working with 3 and 5, we can also cancel those out. 3 divided by 3 is 1, 15 divided by 3 is 5. So now we can multiply across. We have 1 times 2 over 1 times 5. So our final answer is 2/5, which is much easier to work with. Our next example over here for number 6, 2/3 divided by 2/9. Well, I am dividing by the fraction 2/9. So instead of dividing by the fraction, I want to multiply by the reciprocal. So our starting number will stay the same. We're not making any changes to that. I will change division to multiplication. And the fraction I am dividing by, we will use its reciprocal. So instead of 2/9, this will be swapped to be 9/2. Again, I want to simplify where I can. Well, 2 and 2, I can divide those both by 2 and end up with 1 and 1. Next up, 3 and 9. I can divide those both by 3, so we'll end up with 1 and 3. And now I can multiply across, and 1 times 3 in the numerator, and in the denominator we'll have 1 times 1, which is just 3 over 1, or we can rewrite that as just the integer 3. So go ahead and practice working on these other examples in just a moment. We're going to do 2 more practice problems where we are dividing, but this time we are dividing numbers that include a mixed number. Again, just like when we were multiplying with mixed numbers, we need to change them from a mixed number into an improper fraction. Then we can use the same process of multiplying by the reciprocal instead of dividing by a fraction. So for this first example here, 2½ divided by 3/4. Well, we need to change 2½ into an improper fraction. So 2 times 2 is 4. 4 plus 1 is 5. So 2½ will become 5 over 2. Next, I am dividing by the fraction 3/4. It's difficult to do that calculation, so we're going to rewrite this as multiplying by the reciprocal. So instead of division, I will use multiplication, and instead of 3 over 4, I will use the reciprocal, where I flip those numerators and denominators, and use the fraction 4 over 3. Now, if I'm looking at this, I can see that I can simplify because 2 and 4 are both divisible by 2, so we will end up with 1 and 2 in each of those places. So now we can go ahead and multiply across. So we will have 5 times 2 over 1 times 3. And when we multiply those together, we will end up with 10 over 3 as our final answer. For our last example over here, number 2, we have the fraction 3½ divided by the fraction 2⅓. So we need to change both of these from mixed numbers into improper fractions. So we multiply the whole number times the denominator. 3 times 2 is 6. 6 plus 1 is 7. So we end up with 7 over 2. Next up, we're dividing by the mixed number 2⅓, so we can turn that into an improper fraction. So 3 will be in the denominator because the denominator stays the same. 2 times 3 is 6. 6 plus 1 is 7. So I have successfully rewritten this from mixed numbers into improper fractions. Now I can see that I am dividing by an improper fraction, or just by any fraction, and we have a hard time doing that, so instead we're going to multiply by the reciprocal. So our starting number will stay the same. Instead of division, I will use multiplication, and instead of the fraction 7 over 3, we'll use its reciprocal, which is 3 over 7. Now, before I do my multiplication across, I can go ahead and simplify because 7 and 7 are both divisible by 7, so we'll end up with 1 and 1. So now we can go ahead and multiply across. 1 times 3 in the numerator and 2 times 1 in the denominator, so we'll end up with 3 in the numerator, 2 in the denominator, and we have our final answer. Hopefully this review helps you feel more confident when it comes to working with fractions, either for multiplying or dividing. The key thing to remember is that even when you're asked to divide a fraction, it really is just multiplying. So really you just need to be comfortable with using multiplication and simplifying your answer at the end or canceling things out before you multiply. And you also want to make sure you're comfortable rewriting division, where you're dividing by a fraction, as multiplying by the reciprocal.